Hello, good evening. Today is Wednesday, July 22nd, 2020, and I will be presenting on the topic, can AI, that is artificial intelligence, be for good in the midst of cyber attacks and privacy violations? This presentation was supposed to be given at ACM CODASPY conference, and the earlier plan was to hold that conference in New Orleans, Louisiana in March 2020. But because of COVID-19, the conference is now being held virtually. And the conference dates are first week of August 2020. So this is a video recorded presentation to be given at the conference. So I'd like to talk a little bit about how I got into this field, AI for good. My area is in cybersecurity and data science, and there is the initiative United Nations on AI for Good. And so I got involved in this initiative some months ago, just about a year ago. And so since then, I've been exploring on various aspects of AI for good. However, because of cybersecurity and privacy violations, can AI really be for good? So that's the topic of my talk today. And so here's my presentation. So I'll share my screen. Okay. Right, so the title is, Can AI be for good in the midst of cyber attacks and privacy violations? So, artificial intelligence is affecting every aspect of our lives, whether it'll be healthcare or finance and managing our home, autonomous vehicles, and so on. Sophisticated machine learning techniques, especially with a focus on deep learning, are being applied successfully to detect cancer, to make the best choices for investments, to determine the most suitable routes for driving, as well as efficiently managing, say, the electricity in our homes. And without a doubt, AI, and in particular machine learning, data science, data mining, is also helping with detecting cyber attacks. So, in other words, AI is being used for cybersecurity, detecting cyber attacks such as intrusion detection and so on. And we expect to have AI to have even more influence as advances are being made with technology, as well as in various aspects of AI systems such as learning, planning, reasoning, and also explainable AI systems. So while these advances will greatly advance humanity, organizations such as the United Nations have embarked on the initiatives such as AI for Good. And we can expect to see more emphasis on applying AI for good of humanity, especially in developing countries. But there is this big question, and that is, can AI really be for good when the AI techniques are being attacked, and also the AI techniques themselves can cause privacy violations? I'm going to talk about that. And so this presentation, and also I've got a corresponding paper, a position paper published in the conference proceedings, will provide an overview of this topic with emphasis on protecting children as an example. Okay, so AI for good. It's being applied, as I said, for cybersecurity applications. By the way, my talk is a fairly short talk, and I'm only going to talk about the essential points. And I'm also giving references to a number of our papers on this topic. So, what is stream classification? So, streaming data is really important. Why? Because data is emanating from all kinds of devices, like sensor devices, and even from various network attack data, and say financial data that's coming in data streams, this continuous data. And so what do? We use past data to build classification model. and we predict the labels of future instances using the model. And it also helps a lot with decision making. So you can see here big data streams, continuous flow of data, and it's very common in our connected digital world, and it's massive amounts of data. So you can see network traffic streaming in. And then what do? We build a classification model using various machine learning techniques. But when you talk about streaming data, you cannot have just one classification model because the concepts are continuously changing, right? Because data is emanating, data that is valid today may not be valid tomorrow. So what do? We have to be constantly updating or continuously updating the models. So what happens here? So you train the model, and then of course you test it, right? And if it's attack, you go and quarantine. If it's not an attack, you just maybe store it in the server. But from time to time, and that could be every second or days or whatever, as these concepts change, you've got to update the model. As new data comes in, new attack comes in, you have to update the model. So what we do is build an ensemble of models, and then we select the best models, okay? And then discard the models that are no longer valid. So that's really our approach. So we have successfully, and here's one of our papers on data streams, published in IEEE Transactions on Knowledge and Data Engineering with my colleagues at University of Texas, Dallas, as well as University of Illinois, Urbana-Champaign. We started this work for NASA and also did quite a lot of work for the Air Force. Okay, so one application that we focused on was evolving insider threat detection. That means the insiders are continuously changing, right? So what do? We look at various system calls and various other sort of patterns that we think could be anomalous. And then we look at the I chunks, K chunk I, and what do we do? So we do the training with I chunks, and then we build an ensemble of models, extract features, and do the learning. We use support vector machines. And then the I plus one chunk comes in, and then we do the testing. And if it is an anomaly, of course, we quarantine, we extract features and so on, and test whether it's an anomaly. If not, then we'll store it in the database. And so what happens is that it's an ensemble of models. So from time to time, we look at the models, and then we throw away the models that are no longer valid, and then we build some new models. And what is very unique about our work is that in the stream classification area, we do supervised and unsupervised learning. But the main point here is that we can detect novel classes. And that's a major breakthrough we made. And that was about 10 years ago. And we have been applying it for a number of applications. And so what does novel class mean? It's usually when you do classification, the classes are predetermined. But when these models are changing, it's not really a good plan to predetermine these various classes. So you could have a red class and a blue class, but maybe there is a brand new class called a purple class or an XYZ class. And that is what we are trying to detect or build, this new class, right? So we have a number of papers, and what is useful about having this novel class is that we believe, right, we haven't tested this particular thing with lots of data, but we believe that this could also catch zero-day attacks, because zero-day attacks meaning that we don't have like the products from Symantec and so on, they are not going to catch the malware because it's a brand new malware that has arrived. And so because of this novel class, it's not an existing malware, it could be a brand new malware. So that is what we are applying machine learning. So again, the whole topic here is AI for good, right? And we have applied it for cybersecurity applications. In particular, it is for insider threat. Insiders threat meaning that there are people who pretend to be good people in an organization, but they are really very bad people. So in the machine, computers, these insiders, I mean, they pretend to be good processes, and you wouldn't even notice that they are bad, malicious, but they are in the system, pretend to be good, but then they carry out all kinds of malicious activities. Okay, so that's one thing, AI for good. But can AI really be for good if it can be attacked? Because AI techniques themselves can be attacked. So we are using AI for all these humanitarian purposes, right? To help the third world countries to get clean food and water, and also make the people safe. But if these AI techniques are attacked, then there's really no point, because they can give all kinds of bad results. So adversary, what can it do? It can really modify our data, right? And it can learn what the data we are using, the models we are using, and it can try to thwart us. So that's adversarial learning. It's not concept drift. It's not online learning. Adversary adapts to avoid being detected. So concept drift is what I mentioned earlier, right? The concepts are changing. That's why we need to develop these new models. But that's not what we are talking here in this particular case. Adversaries adapting to avoid being detected. It could happen during training time, during testing time. That's data poisoning. And so adversary tries to thwart us by learning our data and our models. And later we will learn what the adversary is up to. So we try to modify our behavior. So it becomes a game playing between both parties, us and the adversary. So here, the red squares are the bad instances and the blue circles are good instances. And this yellow line is the support vector machine boundary line, right? So what is the adversary trying to do? It's trying to make the bad instances look like good instances, because it knows what algorithm we are using, the machine learning model, and the data we are using to train the model. So it's figuring it out, and it's trying to adapt its behavior so that you could see all these red squares have come into the blue circles. So these 5 bad instances will not be detected. So it has succeeded to some extent, right? So what do we do? So adversarial machine learning, we develop something called adversarial support vector machine. So our threat model, test time, deployment time attacks, attacker tries to modify X to X prime. So modify packet length, they can add dummy bytes, good word to spam emails, noise to an image, and so on, right? So this dash line here is the boundary line, right? The black dash line is a standard support vector machine classification boundary line. And so all these red crosses, in this case, are bad instances. The green circles are good instances, right? So what do we do? Because see, we have tried to figure out what the adversary is up to. So we move our boundary line to this blue line here. So the blue line is the adversarial support vector machine classification boundary. So we have moved it. And what happens when we move it? Some of these red crosses, which earlier, with our original line, it would not have been caught, but now we are catching it. And that's what happens here. All of these black stars are really bad instances, but we have caught them by moving this blue line. Of course, you could ask the question, why don't we move the blue line somewhere here, right? If we move it here, then we could catch more of the bad instances. But then we could also have false positives, right? We don't want false positives, nor do we want false negatives, because many of these green instances, green good instances, will be shown as bad instances. So our challenge is to come up with this appropriate boundary line, modified boundary line, for this adversarial support vector machine technique that we have developed. So our paper published is a top data mining knowledge discovery conference, ACM conference. And so where we show, it's a lot of mathematical techniques, right? And we show how we move this boundary from these dotted lines to this blue line, right? So there is a challenge. We have to get the right boundary line, right? And another problem is that we have worked on this for about, for certain types of attacks. So we've got targeted attacks and free range attacks. But in general, in reality, the adversary could have hundreds of attacks, right? All it needs for the adversary to succeed in one attack. We've got to prevent the adversary from all attacks. So it's much harder for us, right? So I'm not saying we've solved this problem. No, we've just handled this problem for some of the attacks, very few of the attacks. But still, our premise is that something is better than nothing. At least for those attacks, I think we have reasonable solutions. Okay, so that's adversarial machine learning, right? So the problem again is, yes, AI is for good. It's being applied for a number of applications, including for cybersecurity, like insider threat detection, intrusion detection, malware analysis. But AI techniques can be attacked. So that's a problem. Another problem is the privacy violations, because what happens is that it's AI techniques. And when I say AI, it also includes machine learning, data science, data mining, the whole lot, right? So we can put collections of data together and apply all these learning algorithms and extract those nuggets that could be highly private, highly sensitive. Or we can, the individual data that we work with, right? Like people's, preferences for certain things, such as say their gender preferences, or some people may not want to give out their weight or their age or various other characteristics. And so, but you want to still apply machine learning to learn properties about population. So in those cases, you don't want to give out the actual values, but you perturb the values. So I'm going to come to that. But the whole point is, we introduced the idea of data mining, security, and privacy. And I did that back in 1996, IFIP 11.3 conference. I gave a keynote and also another keynote at the Pacific Asia Knowledge Discovery Conference in Melbourne. The first keynote was in Como, Italy, where I said that because of data mining, we can put collections of pieces of data together and infer something that could be highly private. And then IBM Almaden in 2000 came up with this great idea where they said that we don't want to give out the individual values. It's the individual values such as weight of a person could be private, but the end result, we want to make it available because we can use that for various, detect that COVID is really concentrated maybe in a particular area or in a particular population. Okay, and so I wrote a landmark paper. I call it landmark. It had many citations. Also, when you are an NSF program director, you set the directions and you fund various activities. So when you write a paper at the SIG-KDD magazine, that is a knowledge discovery in databases magazine, so it gets a lot of attention, right? Because it really spanned a new area of research. So privacy preserving data mining machine learning, this particular idea came originally from IBM, Almaden Research Center. So my work mostly focused on putting collections of data together. Is more the inference problem, infer something that is highly private or highly classified. But IBM came up with this approach where privacy preserving data mining or machine learning, where you have the original data, you add some noise and you perturb, randomize the data, the modified process, and then you have the final modified result. But the end result, you really want it to be the same because you're making so many decisions from the results that are being produced, right? But the individual data values will not be divulged. So that's the whole idea here. So later when I joined University of Texas, Dallas in October 2004, my first PhD student, a lady, Dr. Li Liu, she worked together with myself and my colleague, Dr. Murad Kantarjulu. We co-supervised her. And she focused on privacy preserving decision trees as well as the perturbation methods. So some of the results that the IBM folks obtained that really influenced some of the work that we did for decision trees. And so data mining, security, privacy is exacerbated with big data, data science, and now AI, machine learning, because you have massive amounts of data that are being collected, right? And so you collect this data, you analyze this data, so there is much better possibility now, chance, probability actually, that privacy could be violated. So we hosted a workshop, National Science Foundation, Big Data Security and Privacy in September 2014. And I also presented the results in February 2015 to Interagency Working Group in Washington. Okay, so there's a lot of work that's going on handling privacy due to AI and machine learning. So that's good. So, but there are two problems, right? AI techniques could be attacked, and the AI techniques themselves could cause privacy violations. And so, how can we protect our children, right? Because the most vulnerable population in our society is our children. And protecting our children is a challenge because there's so many child predators and child molesters and child abusers. So how do we protect our children? Can AI help? But now we have technologies to protect them. And I believe no other technology is more suited than AI. Why? Because if we equip our children with smartphones and sensors, which could be quite dangerous, but still, you know, we really need children to have the facility, the capabilities, then we can predict their moods and we can track them and analyze, is this person looking sad because he or she is being molested? And remember, especially with COVID-19, children are now stuck at home or maybe in certain homes that they are not being taken care of. And this could happen not just in developing countries, it could happen anywhere, right? So, and these AI techniques are without a doubt very useful, right? Machine learning techniques could be applied to detect the moods of the children, just one example, and perhaps determine whether they are happy, they are unhappy, and why are they unhappy. So there are so many things that we can do. However, these very technologies could violate their privacy. Why? Because you take the photos from cameras, right? And it could go into the wrong hands. The photos of these children, because we want to take the photos, because when I say we, assuming that we want to protect these children, humanitarians, right? They want to take the photographs and look at the children and see who is being abused and who is not, something like that. And so, but if these photographs could go into the wrong hands, then the predators would know where these children are, the location of the children. So that could become very dangerous because the privacy could be violated. And another problem, what happens if the technologies are attacked? As I said, AI techniques I showed could be attacked. What happens if these techniques that we are using, the very techniques to protect the children, could be attacked by malicious software? These attacks could result in causing more harm, but possibly more harm and grief for the children, right? So because it could give us wrong information and, you know, children may not be attacked, you know, may not be abused and we may think they are abused, or they are abused and we may think they are not abused. So there could be all kinds of problems. So it's critical we develop adversarial AI systems, as I mentioned, as well as privacy aware machine learning techniques. So we need to protect the privacy of the children, but we also need to know what is going on with these children. And so we don't want the AI techniques to be attacked. And so there is this balance, right? The security and safety of the children versus the privacy of the children. There is now an initiative called the Quantified Self Initiative, right? This is, you know, psychologists, sociologists are all studying about, you know, collecting lots of information about people and studying various properties and so on about societies, which is a good thing. But this initiative enables all kinds of information to be collected about humans through sensors and provide them better healthcare and many other beneficial services. But whenever you collect all kinds of information, right, it could be dangerous, right? So the privacy could be violated of the various individuals and particularly also our children. There's also work on privacy aware quantified self. That's something that myself and my colleagues at UT Dallas as well as at Purdue University, you know, we've done some work on privacy aware quantified self, where we say data collection, data storage, data manipulation, data analysis, and even data deletion about the individuals are carried out in a privacy aware manner through various policies. So here is an example where, we are collecting, we have this cell phone or smartphone, and, we give it to various types of people. So here I'm not talking in particular about children in general, the health information, the fitness data, location data, social media, image, all kinds of data being collected. So in the case of what I said for our children, all the information about them, the properties, what they are doing, their daily lives, all of that we are collecting because we want to observe, are they being abused? Are they not? That's our whole idea. But in this particular case, collecting data to see, giving advice to individuals about their health and various other things. But what we are, and then some of the data, we can't really store everything in our smartphones. And so some of them encrypted, stored in cloud storage or anonymized and encrypted data. And then we based on cloud services, we can get the results that we want. So we call this privacy aware quantified self manager running on the mobile device. Okay, so the major aspect of our work is that we say, policies should be guiding everything. What does that mean? We want policy aware data collection, policy aware storage, policy aware analysis, and policy aware data sharing, right? So that is really key to what we are saying. So we have all kinds of policies. Now, who develops these policies? So much of the work that we have done on information sharing, we develop as computer scientists, we specify some policies, but they are really TOY policies, because we are not policy specialists, right? So in the data sharing world, we say, okay, A shares, or John is sharing data with Jane, provided Jane does not share it with Mary. It's like children playing games, right? I'll tell you a secret, but don't tell the secret to anyone else, or particularly don't tell the secret to Mary. So, but that's, to have realistic policies, we need to work with the various policy specialists. So more recently, we've started a collaboration with our school on policy sciences, economics, policy and political sciences. And so, and one of my colleagues and the dean of that school in our university, they have done some work on cyber physical system security and coming up with policies in Colombia, the country, South American country, Colombia. And they have done some very interesting work. So maybe some of this work, developing these policies, we should really be working with the policy specialists. So what I'm trying to say is that giving these cell phones or smartphones to the children, right, or some device, we need to collect the data in a policy aware manner, right? Policies set to guide the data collection, storage, analytics, and sharing. But how do we successfully do that? That's the challenge. So, summary and directions. The main question that needs to be addressed is, how can AI be for good in the midst of cyber attacks and privacy violations? We discussed the attacks on the machine learning techniques and the solutions that are being developed to address this problem. That's the adversarial machine learning, a support vector machine. We also discussed the privacy violations that could occur through machine learning, and we discussed privacy aware machine learning, right? Some aspects I mentioned. And yes, AI is good to help children. We can keep children safe and secure through these various AI and machine learning techniques, but it can also exploit children because it could be attacked and privacy violations. Problem through cyber attacks on AI and privacy violations. We need public-private partnerships to tackle the challenges we are faced with today, right? We alone, when I say we, the computer scientists, we cannot solve the problem. All we do is we can develop technologies, but those technologies have to be put to good use. And that's where we need the policy specialists, the social scientists, and the psychologists, because they understand what children are like, these, child psychologists. So when this information comes back to us and we analyze, it's the child psychologists and the sociologists. They can look and, perhaps figure out, they are the experts. They can figure out whether these children are being abused, right? So that's the challenge. And so we need we also need public-private. So it's just not companies and academia and so on. We also need the government to be involved to tackle the challenges we are faced with today, right? Initiatives such as the UN's AI for Good, it's really a great initiative, and I applaud the United Nations to have started this particular initiative. Should focus, but they should also focus on how the results can be successfully applied to the most vulnerable community in our society, and that is our children. And what we mean by that, successfully applied, and I should have added that, is that, we need to ensure that the techniques, the technologies we are applying are not harming the children. That means the AI techniques have to be secure. They cannot be attacked. Of course, they are going to be attacked, but we've got to develop solutions, right? And such as the adversarial, that's just one example, the adversarial machine learning techniques I mentioned. And also, the other thing is this AI techniques, and we also have to ensure the privacy of these individuals, right? And so I'd like to thank my colleagues, Murad Kantajlu, for the work on adversarial machine learning and so on, and Latifa Khan for the work on applying AI for cybersecurity, right? So the first one is AI techniques being attacked, and then the other is AI for cybersecurity. And of course, Ms. Rhonda Walsh, she's a project coordinator, and she does a lot of, work for us and, enables us to, do our work. And so that finishes my presentation, and I'll stop sharing the screen. And so again, I'd like to stress this point that, our children are our treasure, right? And so, and they are the most important group in our society, because why? They are the future, right? Our children and grandchildren are the future of our society. And if they are attacked, right? If they are being abused or molested or beaten, it is just such a tragedy. There's nothing that's more sad or more cruel than abusing children. And so we have to do everything to protect our children. And the AI for Good, humanitarian purposes, helping children, yes, it's a great thing. But can AI be for good? That's the question when we have cyber attacks and privacy violations. So we've got to do both, apply AI, and at the same time, we have to ensure that the AI techniques are protected and AI techniques cannot harm the children by violating their privacy. And so thank you very much for the conference organizers for inviting me to give this presentation. And I hope we all have a very successful conference virtually. Thank you.